Welcome to Cybersecurity Workshops. In this session, we will be working with user accounts. So we're continuing our discussion of the command line interface thanks to a course by Matthew Vogel from Tidewater Community College. We're on Module 3, so in Module 3, we're talking about working with users and groups. So we started in Lesson 1 talking about the different types of users. So on a Linux system, we learned that there are normal user accounts, there are system accounts, and then there are root or super user accounts. So here in Lesson 2, we're gonna learn some tools to manage user accounts. So we'll dive right in. So we're going to learn some new commands today. We'll learn how to use the useradd command to add users. We'll look at the ID command, the GID command. We'll look at the password command for changing passwords. We'll look at the add user command. This is another way to add users to the system. The behavior is a little bit different than the useradd command, so we'll talk a little bit about that. We'll talk about deleting users using userdel. And then we're going to take a look at two important files on any Linux system that manage the user account data and then the user passwords. And those are the password file and the shadow file. So we'll start with useradd. The useradd command can be used to add users to a Linux system. Basic syntax is, like many Linux commands, useradd, and then command line options, and then we'll be assigning a username. So one of the most common options with useradd is the -m command line option, which tells useradd to create the user's home directory. And this is important. If you create a user account with useradd and you don't use the -m option to create a user home directory, then the user is not able to log in through the command line interface. And that's, you know, for sort of normal users of a Linux system, they're most often going to log in using the command line interface, and without a home directory, they're just not allowed to do that. So here's an example of the useradd command. Useradd is a command that requires root level access. So if you're gonna create new user accounts on a Linux system, you have to have root level permissions. So you're either logged in as root or you are using the sudo command. And remember, we've mentioned previously that in order to use the sudo command, you have to have special permissions on the system. You have to be a member of the sudo group. And as a user in the Virginia Cyber Range on your Linux systems, the student user has sudo access, and so you'll be able to use these commands. The user is created with the useradd command, but will not have a password set until later, and we'll talk about the password command in a minute. So let's take a look at this here. We're going to say sudo useradd jsmith. Okay, so now jsmith is a user. Notice I did not use the -m flag. So if I take a look at we know that home directories are stored in the home /home folder. And we'll see that there's a Jane Doe directory, there's a student directory, there's a Vacker directory, there's no jsmith directory. So we're going to fix that. We're going to say userdel, get rid of that jsmith user, and then we're going to use our sudo again, useradd -m jsmith. Now, when we list the home directory, now there's a jsmith folder, right? So we've properly created the jsmith user account. The ID command can be used to verify if a username is on a Linux system. So this checks to see if a system account exists or not. Very simple syntax. You simply have ID and then the username. And the output of the ID command shows the user's user ID, the user's group ID, and then groups that the user is a member of. So now if I say ID J Smith, I see that J Smith has a UID of 1004. Remember that user IDs of 1,000 or above are normal user accounts. J Smith has a group ID of 1004, matches the user ID. And then the groups that J Smith is assigned to, the only group that user is assigned to is the group with his own name, so his own group. If I do ID student, here's the student account, user UID 1002, group ID 1002. The groups that student belongs to are the student group, of course, the group with his own username. And then, as we've mentioned previously, the student user is also in the sudo group. So that's what allows the student user to use the sudo command. So when a user is created, the user is given a UID. UIDs 1,000 and up, as I just mentioned, are reserved for normal user accounts, and they're incremented for each user added to the system. So they're just going to start at 1,000, 1,000, and then 1,000, 1,002, 1,003, etc. When a user is created, the user is given a group with the same name as the username. So, and then there's a group ID that goes along with that group, and that behaves similarly. The numbers start at 1,000 for normal user counts, and then it's incremented by 1. So now here's the password command. The password command is used to change the user's password. Notice that it's abbreviated, right? PASSWD. So the command is passwd, not really password. And the password command, if you're going to change somebody else's password, it requires root level permissions. You can change your own password without being root, but you have to use root permissions, use the sudo command to change other users' password. And I would recommend, as the student user on your Virginia Cyber Range virtual machines, that you do not change the password for the student account. If you change that password, your instructor is not likely to be able to change it back. And if you forget that password, then you can't log in anymore. So the instructor is going to have to reset your environment. So let's set a password for J Smith. And I didn't use sudo. Now it asks me for a new user password. Notice when I type in these passwords, the cursor doesn't move. So when you're using the Linux terminal, when you type in a password, the cursor is not going to move. That's sort of a unique behavior of the Unix terminal. So it's sort of the Linux terminal. Sometimes people sort of think that, hey, I'm typing and nothing's happening, so it must not be accepting the thing that I typed. It does, in fact, accept the password that you typed, just that the cursor doesn't move. Okay, so now another way to add users is using the adduser command. So that's remember the command we used previously was useradd. Very similarly named, very similar functionality. The difference with the adduser command is that first of all, you don't have to use the -m switch to create the home directory. The adduser command is going to automatically create the home directory with no special switches. You will be required to change the password. So it's not going. You don't have to use the password command to change the password. The adduser command is going to force you to change the password right there. And then you'll also be given the option to enter more information about the user. In fact, you'll be asked for each one of these bits of information. You'll be asked for a full name, room number, various phone numbers, other information. You can leave it all blank, but you're going to be asked for all of it. So this adduser is a very interactive command. So if you're a system administrator who very infrequently adds a user account to a Linux system, or maybe you're a home user and you want to have multiple user accounts on a certain system, the adduser command is probably the best one to use because it sort of walks you through the process, automatically creates the home directory, requires that you set a password. It asks for more context around the user account, which you can fill in or not. But if you're in that situation, adduser is probably the best one to use. On the other hand, if you are a system administrator who manages lots of accounts on a lot of different Linux systems, and you want to script a lot of that interactivity, the useradd command is much, it's much more fine-grained. There's different command line switches to give you different functionality, and so you're not forced to go through this entire process. And so if that's the situation that you're in, then the useradd command is probably the best one to use. But I recommend people use the adduser command in most cases, and it's easy to remember. I don't know, this is how I remember it. I think of them in the two words in alphabetical order. So when they're in alphabetical order, adduser, then that's the one that I am going to use 99% of the time as somebody who's not administering lots of different accounts. And then if I want to use the other one that's going to give me this different sort of functionality than user and add, those are not in alphabetical order. Okay, so we'll take a look here. Well, so let's look at the example out of the slides. So here, sudo adduser, of course you have to be sudo to do this. You have to be root because it's going to do things like create home directories, and it's going to ask for you to set the password, and those are things that require root access. So sudo adduser dsmith, and you'll see it's going to go through ask you various questions along the way. Sudo adduser dsmith. Okay, so adding the user dsmith, added the group, created the home directory, and now it copies files from this etc skell folder. So that's the skeleton, etc skeleton. That is the sort of the default set of things that normally goes into a user's home directory. So it copies all that stuff over. So again, you get this sort of added functionality when you use adduser. And then it requires me to enter the new password. So I'm going to enter a new password. You see that the cursor didn't move when I was entering that password. And then it goes on to ask me for more information about the user. So I can add more info, like I can put in the full name. I can put in the room number. I can put in phone numbers. I can put in other data. Is this correct? Yes, this is correct. Okay, so now I've added a user and I've gone through this interactive process of adding more information about the user. And now if I use the ID command to look for dsmith, then there's that new user. Okay, and then the userdel command can be used to delete users on a Linux system. Syntax is here, userdel -options, username. Most common option is the -r. -r is going to delete the user's home directory. So userdel requires root level permissions. So here, if I look at the home, so here I have Jane Doe, I have J Smith, I have D Smith. So let's say I want to get rid of the J Smith user. I can say sudo userdel -r J Smith, and I get this error. It says userdel J Smith mail spool not found. You can ignore that. This system is not set up for email, so there's no mail spool for any of the users. But now if I try to find J Smith using the ID command, not there anymore. And if I list the home directory, or if I list the contents of the home directory that has the individual user home directories, you see that J Smith is not there anymore. Okay, here's the example we just saw. Okay, we're going to talk about two files and then we're going to wrap this up. One of them is the password file. So the password file, passwd, holds information about user accounts. Password file is located in the /etc directory. If you remember in one of our previous workshops, we showed the password file, may or may not remember that. So so /etc, you'll often hear that called etc, /etc/passwd. So this is etc password. And it's, again, the file that contains user account information. Any user can view the contents of the etc password file, so you don't have to be root to see etc password. The passwords are not located in etc password, okay? So the naming of it is a little bit of a misnomer. The fact of the matter is, back in the very, very earliest days of Linux, the passwords were stored there. First, they were stored in plain text, then later they were stored in a hashed representation. But since you have the ability of any user to see that file, that was deemed to be insecure. So the user account information remains in the etc password file, but the password representations have been moved to the shadow file, and we'll look at that in a minute. So here is etc password, and so I can go to my Linux system on the cyber range, and I can look at the contents of etc password. And here it is, some stuff scrolled up through the top. You see there's all kinds of system accounts. These system accounts have user IDs that are less than 1,000. And then down here towards the bottom, now we start to see some of the actual user accounts. So here's student user 1002, Vacker 1003. Here's D Smith 1001, Diane Smith. That's that information I just included there, right? So that's the user account information. There's the username :X. That's where the password used to go, and we'll see in the etc shadow file. That's where the password representation is there. Then a colon. Then you have the user ID, group ID. Then the other information that I entered about the user, and then the user's home directory, and then the user's login shell. So this, most users are going to be bin bash, and then you see these other system accounts have these user sbin no login as their shell, and that essentially doesn't exist. Those user accounts are not able to log in. So this just goes through what I just talked about. Third column is user ID. Fourth column is the primary group ID. Fifth column is the comments section, which is additional information that you saw there. Sixth column is user's home directory. Seventh column is the shell, bin bash. Okay, the other important file, system file related to users, is the shadow file. This is where passwords are stored. Passwords are stored in an encrypted format. That's a good way to think of it for now. They're not really encrypted. It's a hashed representation of the password, and you're going to learn a lot about password hashing and other sort of techniques like that to obfuscate things like passwords. But for now, you can think of the password as being encrypted in the shadow file. Shadow file is located in the etc directory again, so you hear this referred to as etc shadow. Viewing the shadow file requires root permissions. Here's an example. So here's J Smith, colon, and then all this between this colon and the next colon, which is right here. This is all the quote unquote encrypted representation of J Smith's password. And then you have some other data after that. So let's take a quick look here. So if I were to, so here I am logged in as the student user. So let's cat etc shadow. And what do we think is going to happen when I try to do that? I'm going to get a permission denied error, right? Because shadow is obscured from normal student user accounts. You have to be, you have to have root access in order to see the shadow file. So I'm going to use the sudo command to look at the shadow file. Did I spell something wrong? Oh, sudo cat etc shadow. I'm trying to execute shadow. It's not going to work. Okay, so here we are. Here's the student account, and there's my password representation. It's pretty long. Now, we all know that the student password is student, right? But we have this representation is very long. D Smith down here, again, password representation is very long. I didn't type in that much stuff. when I created that password, but I get this very long representation of a password, and you'll notice that those two password representations are of equal length. It's a bit of, when you learn what hashing is and how passwords are treated, you'll sort of understand why those password representations are of equal length. But you can see that this is sort of meaningless gibberish, and this isn't something that you could easily turn back into the user's password, and that's the exact intent here. If somebody is able to gain unauthorized access to the system and grab this, this list of usernames and their password representations, you don't want them to easily be able to turn that back into their real passwords. Okay, the shadow file is broken down into 9 columns separated by colons. First column is the username, J. Smith. Second column is the password representation, so that's shown here. Then included here is the last password change, so the number of days since January 1st, 1970 that the password has been changed. January 1st, 1970, why do we start there? That's just the Linux default. That's the start of time as far as Linux is concerned. The minimum password age, so you can set the minimum age of a password. That can be left, if it's left at 0, then the user can change the password at any time. You can have a maximum password age, and the default is 99999, which means that there's essentially no requirement to change the password, but there are some organizations that have a policy that says the password has to be changed every 3 months, for example. So you could put in 90 days or whatever. Password warning period, this is the number of days prior to the password expiring that the user will be warned. So you can have this thing set up so when the user logs in, it says your password's going to expire in 7 days, and that tells them that you need to go ahead and change their password. There's this password inactivity period. So after the duration of the inactivity period, an account will be disabled, or it will be deleted. And that is just to have a management system for administrators. If they have systems that have a lot of users that sort of come and go, like students, for example, you might set an inactivity period so that if a student is finished using an account, on a system, then 30 days later, the account's just going to automatically get disabled and deleted. You can set account expiration, similar thing. Eventually the user account will go away. Then there's this, this reserved for future use. So that's not unusual in systems like this, where when it's created, the creator says, well, there may be some features we want to add later, so I'm going to add some fields that are reserved for future use. Okay, so with that, I would encourage students to go ahead and do the lab exercise that's associated with this lesson, and teachers and faculty are going to have to provide that lab to your students. So thanks, and we'll see you next time.